Hello, these are the notes for section 8.1. So chapter 8 is on covalent bonding. So in chapter 7 we talked about ionic bonding and metallic bonding. Now this chapter is about covalent bonding. So there's three types of chemical bonds. So section 8.1 is on molecular compounds. The learning goals are to identify characteristics, including the number of valence electrons, that allow you to differentiate between ionic and covalent bonded compounds, and then identify the information that a molecular formula provides, and identify diatomic compounds, ionic compounds, and covalent compounds. The vocab terms that you need to know are covalent bond, molecule, diatomic molecule, molecular compound, and molecular formula. Okay, so the first part here is on covalent bonds. So this is one of your vocab terms too. A covalent bond, that's atoms that are held together by electrons that are shared between atoms. So in chapter 7, we talked about ionic bonds, and that's where we had electrons that were transferred from one atom to another. The covalent bonds is just a different way that atoms are held together. So it's caused by sharing of electrons between the two atoms. And then both nuclei are attracted to the shared electrons. So that's the force that's holding the two atoms together. It's kind of like a tug-of-war situation where both nuclei are pulling on the shared electrons. That's what keeps the atoms together. Covalent bonds occurs between nonmetals, which have 4 to 7 valence electrons. So this is going to be the elements that are in the top right of your periodic table. And just like in the ionic bonds, the reason for a covalent bond is to get the atoms to where they have a stable electron configuration. So they're trying to satisfy the octet rule. So the electrons that are being shared will count towards the octet for both of the atoms involved. So all these atoms are trying to get to where they have 8 valence electrons and follow the octet rule. Now the exception to this is hydrogen. Hydrogen only needs 2 electrons to be stable. That's called the duet rule. Okay, the next thing is molecules. So a molecular compound is a compound composed of atoms that are connected by covalent bonds. So they're sharing of electrons to reach the octet rule, or have 8 valence electrons. And then a molecule is the representative single particle of a molecular compound or a covalent compound. So this is an example of a few different molecules on the bottom of the screen. There's the carbon dioxide, where there's 1 carbon and 2 oxygens. That's just a picture of a molecule. There's the glucose here, where you have C6H12O6. So all those atoms are connected by shared electrons. And then water is also covalently as a covalent compound. It's a molecular compound, so it's held together by covalent bonds. Next we have molecular formula. So molecular formula is a chemical formula for covalence that show how many atoms of each element a substance contains. It represents 1 particle of a compound. This may not be the lowest ratio, because we saw with ionic compounds, that was always the lowest ratio of the ions in the compound, that they give you a charge of 0. That is not the case with molecular formulas. It doesn't have to be the lowest ratio. And here's a few examples down here. You have H2O. This H2O2 is hydrogen peroxide. This is an example where it's not the lowest ratio of the atoms in the compound. You also have CO2, carbon dioxide, and C2H6. This is another example where it's not the lowest ratio. Then there's diatomic molecules. That's where you have 2 atoms of the same element joined by a covalent bond. So this occurs naturally, and this occurs because the atoms are just more stable as a pair rather than an individual atom all by themselves. So they do this for reasons of stability. They're mostly gases, and there's 7 of them that you need to know about. So here's the list right here. We have hydrogen, oxygen, nitrogen, fluorine, chlorine, bromine, and iodine. Now most of these are in the top right part of the periodic table, the elbow, which goes from N over to F and down to I. That's 6 of those diatomics. The other one is hydrogen in the top left corner. We use this mnemonic device to help remember them, just call them Brinkelhoffs. So the Brinkelhoffs are our diatomic molecules. So I would highlight these on your periodic table so you know where they're at, okay? Because this concept of diatomic molecules shows up quite a bit, okay? And again, they exist as a pair because they're just more stable that way. It allows them to get to an octet and be stable. Okay, and the last part is for section 8.1 is you want to know the differences between covalent and ionic compounds. So you want to copy down this whole table right here. Don't worry about the drawings down here, but make sure you get this table up here because it shows some of the key differences between the covalent, which we're covering in chapter 8, and the ionic compounds, which we covered in chapter 7. So the representative particle is the smallest part of something that is still considered that thing. So for a covalent compound, it's a molecule. For an ionic compound, it's called a formula unit. And you can see the different properties that we have right here. So you just want to copy all of this down, okay? The key thing is this last line right here. This is how the bond forms in the first place. In ionic compounds, electrons are transferred, but in a covalent compound, electrons are shared. Okay, so pause the video if you need to and copy down this whole table. And we're going to add to this on the next slide too. Okay, you also want to get this information down too. So just make this another table in your notes and copy this all down. So we have covalent bonds and ionic bonds, and it just highlights some of the key differences between them. Okay, so copy all that down. This bar right here is to cross out something that you don't need to know. But you can pause the video and copy down that information. And then when you're done with that, you're all done with the section 8.1 notes. All right, have a good day.